This is a look at the 2019 paper 2 question 8, which is a question on inferential statistics. So we have a lot to do with our normal distribution here, 95% confidence intervals, hypothesis testing, and p-values as well. Okay, so let's take a look here at the part A. So we have a motoring magazine collecting data on cars in a particular stretch of the road. Age of the cars, 800 cars were recorded, 174 were new. Find the 95% confidence interval for the new cars on the road. So first of all, we have to think about, are we looking for a confidence interval for a mean or a proportion? Okay, so we have this proportion here. So we know we're looking for a confidence interval for a proportion. Now, I have the log tables just printed down below. For a proportion, okay, if we go to the log tables here, we see proportion. We should be thinking it's got to be our 95% confidence interval, which involves this part of the formula, which is, that's definitely going to be the p hat. So let's look. So we should have our 95% confidence interval as follows: p hat plus or minus 1.96, always 1.96 for our 95% confidence intervals, p times 1 minus p all over n. Okay, and remember, in this case, p hat and p will be the same figure. So the figure for p hat is our sample proportion. So p hat is our sample proportion. That will be our 174 up here over the total. That is our sample proportion. So p hat equals 174 over 800. So just put that in the calculator, see what we get there. So that is the same as 0.2175. So now to create our confidence interval, we just need to look at 0.2175 plus or minus 1.96. And then we have the square root of 0.2175 times 1 minus 0.2175 all over the n, which has to be 800. Okay, so if we put this in, then 0.2175 minus 1.96 times the square root of this 2175 by 1 minus all over 800. So put in this exact sum here, okay, except I just choose minus first, and that gives me 0.1889, and it says correct just 4 significant figures, so stopping at 1889. Then I change it to a plus and see what the upper end of the interval is, and to 4 significant figures I get 0.2461. So that is my 95% confidence interval for the proportion in that question. Next, it says data on speeds of the 800 vehicles is normally distributed with an average speed of this, with a standard deviation of this. So what proportion of cars in the stretch roads would you expect to find traveling over 95 kilometers per hour? So with this, we can say we're looking to find what is the probability that a randomly selected car will be going at a speed greater than 95 kilometers an hour. Now, what we need to do with this is, if we want to find that, we need to convert it into a z-score. So let's go down here, have a look. So our standardizing formula will convert a standard score into a z-score. Okay, so we take our normal statistic, which is our statistic given, which is a 95. We put it into that formula. So it's x minus mu over sigma. So our z-score then is this. So we have 95 minus mu, which is this, all over sigma, which is 12. So we pop that into the calculator as well, 87.3 all over 12. And that gives 0.64 to 2 decimal places. So we'll take our z-scores to 2 decimal places. So it says, what proportion would you expect to find traveling at over 95 kilometers per hour? Now, if we want, we can draw out a little rough sketch of our normal distribution. Doesn't really matter how accurate it is, just to see what we're looking at here. So 0.64, 0 is always in the middle. So 0.64 comes to the right of that, somewhere around there. Again, the accuracy, this doesn't matter too much. We just want to see what side we're looking at. So it says we want to find what's traveling over 95 kilometers per hour. So it has to be this bit out in front here. So if that's just a smaller section, so it's smaller than half, we need to do 1 minus whatever we get for 0.64 when we look at it in the tables. Let's come down here, and if I go to 0.64, that gives me this one here. So 0.7389. So we should have 1 minus 0.7389, which is just equal to 0.2611. So that is the proportion of cars which you would expect to be traveling at over 95 kilometers per hour. So two nice enough parts there so far. Next we have, driver was told that 70% of all the speeds recorded were higher than his speed. Find the speed at which this driver was recorded. Now, this is going to be a little bit different because we're going to have to do pretty much the opposite of what we did in the last one, which is first find the z-score and then convert it into an actual statistic. So we had in the last statistic, converted into a z-score, and then found the proportion on the table. This time they give us the proportion. Again, I might just draw, you don't actually have to do this, but just to see, if we draw a rough sketch of a normal distribution, someone was told 70% of all speeds recorded were higher than his speed. Well, if you think about it, his speed must be less than the average of 70% were above him. So what we could say is this is the z-score that corresponds to his speed. Let's call it z1. 70% of people were going higher than him. So what we should do is we should go down to 0.7 in the tables, but I said we're doing the reverse. So we need to find 0.7 actually in the tables. So we want to find the number that is closest to 0.7, which is that 0.7019, actually 0.6985, that would be closer, won't it? So that would be a z-score of 0.52. Now, if I come back up here, that z there cannot be 0.52 because it's less than 0. So the z-score here is actually going to be equal to minus 0.52. Now, we do need to find his speed. So we need to come back down to, just get the formula again, so the standardizing formula again, and use that to find the actual speed. So the x value will be the actual speed. So z equals x minus mu over sigma. Now we're going to take mu and sigma from the last part. So 87.3 and 12. Okay, so now what we're going to do with this is take the 12, multiply it up to the other side there. So minus 0.52 times 12. That just gives minus 6.24. Minus 6.24 is equal to x minus 87.3. So you now have to take the 87.3, add it to that side as well. So that's just going to give us an answer of 81.06 as the actual speed. And that's our answer for this. So that is the speed. I'm just noticing, check the question again. Correct the nearest whole number. So I suppose you have to say that's going to be equal to 81 kilometers per hour to the nearest whole. Okay, so find the speed. Yeah, so that's what we're done. Now, part B looks like it's going to be something new compared to the last thing. It's still following on with this theme of the cars. So it says we had a motor magazine recording speed of 100 passing cars. Okay, they have a hypothesis test. First thing is important. 5% significance level is normal. And they say the p-value is 0.024. Okay, what can we conclude about this p-value? So p-value is less than 0.05. That's our reason, first of all. Because the p-value is less than 0.05, you would reject the null hypothesis. Okay. To determine whether the average speed had changed, so we would say reject null. So speed has changed. Okay, so not too bad for that one either. This last part is going to be a tiny bit trickier, I think. So it says here they found that the average speed of this sample was lower than the previously established average speed of 87.3. Find the average speed correct to one decimal place. So we need to work backwards from our p-value here. So remember that our p-value is, whenever we look at our distribution, if we have a test statistic which is outside of minus 1.96 or plus 1.96, we'd be rejecting the null, but the p-value would always just be the area of these two bits here and here. So they would have to total up to 0.024, okay, which means that one of them, so this one, I'm picking the one on the left because it says it was lower. So we should take the speed lower than the average. So that on the left there is 0.012 because that's half of 0.024. Now, what are we going to do with that 0.012? Well, what we'll have to look at is what is going to be in the remainder outside here. If that's 0.012 all the way up to the top, that's going to be, because we can't find 0.012 in the z-scores, that's going to be 0.988. Now, what do we want to do with that? So we want to find the z-score that corresponds to, so there's a z-score there, that corresponds to 0.988. So let's go down again to the tables and look for 0.988. Can. So where is 0.988? 9881, I think there. So we have 2.26, looks like our z-score. Similar to the last one though, because it is less than 0, our z-score will not be positive, it'll have to be negative. Sorry, again, there was 2.26. So it's going to have to be negative 2.26. So our z1 is equal to minus 2.26. Now, that's working backwards from our p-value, which is a little bit different to straightforward use of the p-value, but that's obviously not our final answer though either, because it does say find the average speed of the cars in this sample. So to do this, we would have had to find a test statistic. Okay, so that would be the test statistic in the hypothesis test. So working backwards kind of from our hypothesis test, to get our test statistic, you would use this formula here. Okay, but again, I said we're working backwards, so we actually have the z in that. So let's put in our z as minus 2.26. What do we want to find? It says find the average speed. Okay, that must be the x bar in this. Okay, so x bar is what we want to find. Do we have mu? Well, it said the previously established average was 87.3, so that would be our mu all over. And then we'd have sigma over root n. Well, we can take our standard deviation as 12 from the left-hand side over here, 12 kilometers per hour. So that's our sigma. And then our n is going to be how many were in the sample. So I think they told us this already, did they? So if I look up here, speeds of 100 passing cars. Okay, so that is the 100 up there is the amount in the sample. So that's over root 100. Now, looks a little bit messy, fractions within fractions. Root 100 is just 10 though. That's not too bad. I can take this and multiply it up there, but remember 12 over root 100 is the same as 12 over 10 is just 1.2. So I can take minus 2.26 and times it by 1.2, and I get minus 2.712. Just put it down here. Minus 2.712 is equal to x bar minus 87.3. And then lastly, what we'll do is we'll just take the 87.3, the minus 87.3, bring it over and make it plus. And then we'll find that we get x bar is equal to 84.588. And then just carefully read the question again. Maybe missed this again. Correct to one decimal place. So we would have that equal to 84.6. And it says average speed. So this is again kilometers per hour. So that's our final answer there. And we have a long question on inferential statistics, 45 marks, so not the longest of long questions, but there is a decent amount in it. There's some not too tricky parts there. A part 1 and 2 aren't the worst. I know we have to work backwards from our Z score in A part 3, but still not the worst for some of the exam questions. B part 1, you could catch out, but B part 1 is very, very simple. Once we spot it, we're just seeing, are we rejecting the null? And yes, because the p-value is less than 0.05, we must reject the null. Last part, probably the main tricky bit in it. We have to use the p-value to get the test statistic, and then from the test statistic, use that formula at the top of the log tables on the right there. Use that formula to find x bar, because we have z found from the p-value, we have mu, and we have sigma, and we have root n. There we go. That is the whole question done.